In this video, we are going to set up public key authentication for SSH. It is a much more secure and convenient way to authenticate ourselves for the server. In this example, we are going to generate an RSA key pair and copy our public key to the SSH server. The client is going to be the Kali host in this example, and the server is going to be a Raspberry Pi with this IP address. Normally, when we want to authenticate and log in into the remote server, we need to type in the password for the remote user, in this case the Pi user. And then we have our login shell and we can execute commands remotely. In this example, we are going to configure a different method for SSH authentication, and we won't use our password. First, let's exit the server, and we need to generate a cryptographic key pair for our user on the client side. So let's enter the SSH directory in our home folder. It is usually empty, or only the known hosts file can be found here. This file is populated with the public keys of the servers we have accessed before, but we don't have to do anything with this file. We are going to use the ssh-keygen command to generate our public and the corresponding private key. With the -t switch, we can specify the key type or the cryptographic method we want to use. It can be RSA, DSA, ECDSA. In this example, we are going to use RSA keys. It is maybe the most popular method, but the basic principles are the same for every key type. With the -b switch, we can specify the key size. Obviously, the longer the key, the harder it is to crack. Usually, for today's standards, keys with 2048 bits are appropriate. And that's all we need to specify. It asks the name and the location for the private key. We want to save it in this directory with this name. So let's just press enter. It asks for a passphrase for the private key. So it is similar to like two-factor authentication. So to authenticate, we are going to need the private key, and we are going to need to unlock the private key with the passphrase. Now we are not going to use passphrase, but I will show you later how this works. So I just press enter and leave it blank. Let's check the contents of the public key. It looks like random gibberish. To simplify things, these keys are mathematically connected. What the remote server encrypts with the help of the public key, we can only decrypt that message with the private key. And there is no mathematical operation to derive the private key from the public key. That's why we can share it with anyone. So now what we are going to do is we are going to copy this key to the server and place it in a given file. I will show you first with a long command, and later I will show you a utility which can be very helpful in this situation. So with the pipe symbol, we are redirecting the output of the cat command and use it as an input for this command. What we are doing here is we are appending the contents of this file to the authorized keys file on the server. So from now on, we can use our RSA keys for authentication without providing our password. So let's test it. No password asked. Let's see what we have done. So this is our public key, what we have seen before. So as long as this key is present in this file, we can use our private key for authentication. I will show you a much simpler way to copy our public key to this file. So I am going to delete this file first. So now we can't use our private key for authentication. We have to provide our password. Now I'm going to use the ssh-copy-id command to do the same thing what we have done before. So copy the public key to the authorized key file. We didn't have to provide the file name. The command automatically looks for our public key with this name. So let's test it. No password asked. The public key is placed to the authorized keys files the same way. I would like to show you an interesting option in the SSH server configuration file, and this is called password authentication. So this option is enabled by default. If we set this option to no, we wouldn't be able to authenticate ourselves with password. I will show you. And restart the daemon on the server. So from now on, if my private key is not present in my .ssh directory on the client, I can't access the server at all. So if I rename my private key, for example, the client won't find my private key because it is searching for a file with the name id_rsa. But with the -i as identity switch, I can use a different file name than the default. Now let's assign a passphrase to our private key to make it more secure, which I didn't do before. We can do this with the ssh-keygen -b command. It asks for the private key and for the passphrase. So it works like two-factor authentication. Besides the password, we also need to provide the corresponding passphrase to unlock the private key. But if we do this, we might encounter a problem if we use automated tasks, which use SSH for copying files, for example. For example, if we use a cron job or a systemd timer unit to automatically copy files. So we have to provide our passphrase beforehand, so it won't be asked by HCP, for example. And this is what SSH-agent is used for. It is usually running in the background by default, but if not, we can start it with the following command. And we can add our private key with the following command. So if we do this, this process stores our passphrase while running in the background, and we don't have to provide the passphrase anymore.